So I finally launched my suggestions.webdevcoding.com website, which allows my subscribers to come in here and submit a video idea, and then others can come through and upvote on their most favorite ideas. And I will try to work on the top voted one. No promises, but that's the goal. But in making this app, I decided to bring in server sent events so that I can update the users in real time when the tags of an OpenAI call finishes. That's kind of like a background process. So I'm going to be talking about server sent events in this video, and hopefully you guys can learn a little bit about them. So a quick demo. I have this application running locally. If I go to submit idea, I can say a video about SSE. And when I click create idea, what this is going to do is it's going to kick off a request to my backend. And if I look at the network tab, you'll see that there is a request that says event source. Okay. This is basically a server sent event connection. This is a text event stream. It's keep alive. It's always going to be connected to my server so that my server can send back events the moment they finish. And if you look at event stream, you will start to see ping messages come in every 30 seconds so that the client can keep this connection alive with the server. Now let me try to document this out as I'm building this. So we have a user and they are going to try to create an event. So submit event, and that gets sent to my server. Pretty straightforward. But what I also have is the moment that this application spins up, it's going to create a SSE connection. And then step 2, the user is going to submit an event. So I'm going to click create idea, and I want to point out I'm using optimistic updates. So like this will be instantaneous regardless of what the network speed is. It's very fast. I tried to make this as like polished as possible. And I'm going to talk about that in some more videos of how complex web applications can actually get, even if they look simple. Let's click it. Notice that it instantly gets added and we have a generate tags spinner. I know it was fast, but it showed us the spinner, and on production takes a little bit longer. So we had the spinner, but then if you look at the server sent event that came in, you'll see that we get an event for tags generated. It tells me which idea was updated, and then it tells me the user ID and some other information about that updated thing. And that allows the UI to basically flip that spinner and show all the tags. As of right now, I'm just revalidating this idea query, so it'll refetch the latest information. Probably what I should do is pass back all the tags that were generated, and then I can just insert them directly into the data without having to do yet another network request. And that's about it. So like if we were to fully map out what's going on here, we submit an event, and then this is going to go to OpenAI. So we have OpenAI. It's going to generate tags based on the description and title. So I'll go here. I'll say 3 and generate tags. And then that gets obviously stored in a database at some point. So we have a database. I am using Postgres here. And so we're going to store those tags. Now I will state that this is a background process, right? This can take, a second. This could take 5 seconds. It depends on the load of OpenAI. And so I actually kick off a promise behind the scenes that'll eventually resolve. And when it's done, it'll then send a event to the server. So I'm going to go ahead and say step 5 is send SSE event. And then the client will update and show the latest tags that were just generated. So this is almost there. I did leave off some stuff. Like after step 2, we actually store the idea. So step 3 be store idea like this. And then the request actually resolves. So like send back, send response. And then behind the scenes, technically we kick off the generate tags. We then store them, and then we send off the SSE event. So even this small little application, there's a lot going on behind the scenes just to get a nice user experience of letting the idea show up as fast as possible, but then behind the scenes kick off the OpenAI call to generate the tags, and then we have to add them to the idea and notify the user that they're done so that their UI can update. And I will state that this is only updating the person who actually submitted the idea. If someone were to log in like right after someone submitted an idea that doesn't have tags, they're just going to see a spinner. And honestly, I don't think I even handled that edge case. Like it's not broadcasting events to all users. It's just broadcasting an event to the person who created the idea. So even with this simple functionality, it's pretty complex. And like, this is honestly why I just use Convex for all my side projects, because it just handles all of this. The moment you update data, it just notifies all users who are subscribed to that data. So a little shout out to Convex there. I still love Convex, but it's fun to kind of mess around with the more lower level stuff, the Postgres, the server sent events to understand how it kind of works, because in order to build your own convex, you'd probably have to learn a lot more about WebSockets or server sent events. So that's kind of the architecture of how it all works. I do want to walk you through some code so that you can actually like maybe map the code to this idea. So let's go over to the code base. I have a submit idea form, and this is going to call a create idea mutation. So basically this is like a hook that wraps a TanStack server function, and notice that we have like all this optimistic update going on. It's super complex just to get something simple. It's crazy. So if we click on the create idea function, this is where the backend logic starts to run. And you can see I basically check for profanity and I filter that stuff out. I make a new idea and I insert it to my database. But here is the fun part. This is where I kick off an asynchronous promise to basically generate those ideas in the background. And if we were to go and look at this, all this is doing is connecting the OpenAI, passing in the information about your title and description, and then we generate 3 to 7 relevant tags that describe your idea. And then we update the database to insert those. And then I'm tracking how many ideas that you've actually like generated, because I don't want someone to abuse my system. So I do have a hard limit of how many generations people can use. And I'll go through and update it and increase it if people are actually uploading ideas. Over here, insert tags and link them to the idea. So this is actually inserting those tags into the database like I mentioned here. And then finally, the server sent event stuff. So over here, there's a server events.emit tags generate. And this is going to send that event to that user ID and also send in the tags that I generated. So I should probably talk about how is this thing even set up from the client side. So if I go to the client, there's a hook called use server events. And the way this works is we basically try to connect to an API endpoint, which I'll talk about in a second. And we basically just listen for messages. So over here, we basically check if there's a tag generated message. We then go through React Query and just like invalidate various things. So like we have to invalidate all the tags so that the stuff on the right can refresh, because sometimes you'll upload a new idea that has new tags you've never seen. So we have to refresh this for the user. And then additionally, we want to refetch just that one idea that updated. So I basically say, hey, query client, fetch query, and that'll call a server action to basically fetch the idea from the database. Again, I could probably optimize this and just have the tags that we already have and just inject them directly into the store. But this was a quick little hack to get it working. So in my idea card, which is basically what is representing this, there is a query called use idea hook that is basically getting that same idea, but I have it enabled false. So I don't want this to run, because if you load the page with 100 ideas, I don't want to do 100 different GET requests to the backend for every single one. I just want this thing to be set up in the component, fetching and listening for that that query key, so that later on when the client gets it, when I call this, it's actually going to just refresh that one component. And then I basically just update some state to have it kind of like display, because again, when all the ideas load, you get like an array of tons of ideas. All right, I think I'm getting into the weeds of complexity, so I'm not going to talk about that. But here on the client, this is how it's all working. We should probably talk about the backend. How does this events endpoint kind of work? So I'm going to search for money sign, and we're going to go to events. And let's read through this. This is a TanStack start API endpoint. Basically, the user makes a GET request, and that's going to create a readable stream so that we can actually keep a connection open with the client and like send over messages. So we have a controller here where we can encode messages. For example, we're going to send over a connect message to the client here. Okay, we have this helper function, handle event, and this is basically, we have an event emitter. So if I go up here, we're basically just creating an event emitter where we can emit events internally on the API. So like if any class or component in the API needs to emit an event, like the OpenAI logic we talked about, that can trigger an event emitter. This is kind of like a global thing that's shared all across the backend API. And so this is what's listening for that. If anything were to submit a tags generated message, we listen to it, and that's just going to stream down that event to that user if the user is matching the ID of the event. Okay? Again, you can have like a ton of these already currently running concurrently. Like you could have like hundreds of these open, because every time a user opens the app, it's going to have a long-lived connection. So basically all those readable streams need to listen for an event to say, hey, tags were generated, and then it can send that event over to the user, the client, and then they can actually like refresh and show. We also got the ping interval over here. So every 30 seconds, it basically just sends over a ping message. And then if they disconnect, we basically clean up that ping interval. And then we also want to listen for when they abort their connection. So if they close their browser, we got to make sure we clean some stuff up. And then finally, you return the response. So this is actually what tells the client, like the browser, to like keep that connection alive. Just have to send back a couple of headers and then also send back that stream. Okay, super complex. And now that I kind of talked out loud about this, I don't think that was a very good explanation, especially if you guys are a beginner. So I think we should dive a little bit more into how this is kind of works. So the server is going to accept a request from a user at a /events endpoint, okay? Which is what you saw in the browser and kind of the code that I talked about. And this thing is going to invoke my controller over here that we talked about. So the readable stream. And if you think about it, this thing is basically kept alive until user disconnects, okay? And that's where we basically have this server events on. We have this event emitter. So over here, I'll say like event emitter. This is global and it's shared for all code in the backend API. So we basically have this thing bind to the event emitter and say, hey, when a message comes in, when tags generated event comes in, we then have to do something to basically pass that message back to that user's connection. So we send over forward the message if user ID matches. I'm going to go ahead and just refactor this a little bit. I don't think I'm doing a very good job to explain this, but a user connects to the server. The server basically spins up something called a readable stream and then streams back the response. And you could, again, have like a ton of these, right? And so all of these have to basically bind to the event emitter and say, hey, like, when the message, the tags generated message comes in, when tags generated event happens, then we basically need to forward the message back to the user. But the thing I didn't mention is that there's the OpenAI stuff that's running. So somewhere else in the backend logic, we're calling OpenAI as like a background process to generate the tags. So somewhere, something generates tags, and then that thing is actually going to send an event. So emit event that tags generated, and it has a user ID and it has like tags. And I think that's kind of all you need. And this event has a user ID on it. And so when we emit that to the event emitter, and all these readable streams are kind of bound to that listening, eventually one of them will have a user ID that's important. So like this will have a user ID. One of these will have a user ID that is kind of listening for any events that have a user ID too. And then that's going to forward it to the correct user. All right, I kind of feel like a mad scientist right now, but that's kind of how it works. Now, there are huge limitations to what I just taught as well. One of the main limitations is that this really only works on a single VPS. The moment you try to have multiple VPSs behind a load balancer, how do you know where you need to send the event? Because some users might be connected on server A, but the request to generate the tags might have happened on server B. So all the other servers need to get notified that, hey, there's been like a tag that's been generated. And you go and like refresh the UI for these people. And usually what you end up doing is having some type of centralized message broker that you have to have running Kafka, RabbitMQ, ActiveMQ, or use some type of existing service that handles broadcasting all these events to the right user in the right UI. Now, this is the same with WebSockets, right? Whenever you have a persistent connection with a server, you have to be connected to the same server which has the data and knowledge that the data is changing. So either it's SSE or WebSockets, it's the same idea. So typically this type of approach, much easier if you just have some type of polling. So every 5 seconds or 3 seconds after you create the event, inside of this component, you can set up an interval to just have it keep fetching the latest information to see if it's done. And for the most part, I would probably recommend just doing that approach. It is going to put a little bit more strain on your API because your clients are like making requests every second to say, hey, is the data there yet? Hey, is the data there yet? And it also removes the necessity of having a stateful service. I think the whole complexity that I just demoed here is basically because we have a stateful server. And having just a REST API, it's all stateless. You don't have to worry about keep alive connections. It can make this a lot easier if you just pull. It's not going to be the best user experience because honestly, depending on your pull interval, you may feel delay, right? The event and the tags could have been finished 3 seconds ago, but then finally the UI decides to pull to get the events. So that's probably something you have to consider if it's even worth it, doing all this complexity or just do a polling interval and call it a day. And I will say that even my application I've deployed, it's still broken. Like it's not working. I just tested this morning and it's like not generating the tag. So I got to go now debug and figure out what's going on. But I think this actually failed for a good reason. Like because if I refresh, the tags are still not there. So I don't know what happened. Maybe I don't have an API key deployed or something. And like, I don't know what's going on here. I need to go log into Railway and see maybe if there's an exception getting thrown. I will say that since I am kicking off like a background asynchronous process, I don't know if Railway is like killing the request because it got a response back and not letting this background process finish. Or maybe I don't have my API key set up correctly. I really don't know. I have to go debug that. But again, I guess I wanted to just demo and explain to you how you can kind of set this stuff up. And honestly, I don't recommend it. I would just recommend paying another service that does all this stuff for you because this is not complexity that you want to spend time maintaining and setting up. Like just literally a service that you can just send a message to and then have it automatically broadcast to all the users who care about it. Probably a better experience and better developer experience. Much easier to maintain. Or probably just use convex like I said. Anyway, I hope you guys enjoyed this video. Have a good day and happy coding.